Good morning, my dear students of first secondary. Today we are going to start our first lesson in geometry for the second term. This lesson is called directed line segment. Let's go. Geometry, first secondary, lesson 1, directed line segment, prepared by Mr. George Milad. Lesson 1, scalar quantity and vector quantity. The quantities which we deal with in our life are two kinds. The first is called scalar quantity. So what is the scalar quantity? It is a quantity determined completely by a real number, which is the magnitude of this quantity. So the scalar quantity is a magnitude. It has a magnitude determined completely by its magnitude. For example, length, mass, time, temperature, volume, and distance. And the second kind is called vector quantity. So what is the vector quantity? It is a quantity determined completely by a real number, which is the magnitude of this quantity and the direction. So the vector quantity determined by two things, magnitude and direction. For example, the force, displacement, and velocity. Okay? Force, displacement, and velocity. Okay? Now we are going to study the difference between distance and displacement. Let's go. First, the distance. It is the length of the actual path covered during movement from position to another. So it is the length of the actual path covered during movement from a position to another. And it is a scalar quantity. Why it is a scalar quantity? Because it is determined completely by its magnitude only without direction. So the distance is a scalar quantity determined completely by its magnitude only. And what about the displacement? The displacement, it is the smallest distance between the starting point and the ending point. It is the smallest distance between the starting point and the ending point, and in the direction from the starting point to the ending point. That is to say that it is the distance covered in a certain direction, and it is a vector quantity because it is determined completely by its magnitude and its direction. Okay? Okay, let's go to our first example today. In the opposite figure, here we have in the opposite figure, if a body moved from the point A, if a body moved from the point A east to the point C, from A to C, okay, then return to point B. Okay, so the body moved from point A to point C, okay, then return to point B again. He walks from A to C and returned back to B again, okay, to the point B west. Then the distance covered by the body equals how many centimeters? The distance here, it will be 9 centimeter plus 6 centimeter. This is to the east, plus another 6 in the direction of the west. Here from A to B, it's 9 centimeter. From A to C, it's 6 centimeter. Then back again, okay? From C to B in the west direction, so the distance will be 9 plus 6 plus 6, so it will be 21 centimeter, okay? So this is the actual path covered during the movement. So here the distance covered by the body is 21 centimeter. Okay, and what about the displacement? Here we want to find the displacement from the point A to the point C. Here the body start from point A to point B, and from point B to point C, then it returned back to point A to point B. So this is the displacement from A to B, the displacement from the starting point to the ending point. So the displacement is from the point A, the starting point, to the point B, which is the ending point. So the displacement is 9 centimeter. Okay, the displacement is 9 centimeter in the direction of east, in the direction of east. Okay, we all know the direction north, south, east, west. Okay, so it will be 9 centimeter in the direction of east. Okay, let's go to another example. Another example. If a body moved from the point A distance 12 centimeter, the body moved from the point A. Okay, here the body start moving from the point A distance 12 meter to the east, 12 meter to the east. Then change its direction and moved 5 meter, okay, 5 meter to the north, okay, 5 meters to the north, and stopped at the point C. So he stopped at the point C. Then the distance covered by the body, it will be AB plus BC. The distance covered equal AB plus BC. So it will be 12 plus 5, so it will be equals to 17 meter. And what about the distance? Okay, the distance is AB and plus BC. And what about the displacement? The displacement is the distance from the starting point to the ending point. Okay, the displacement during the movement is the length of AC, from the starting point to the ending point. So this is the displacement in the direction of AC. How can we find the displacement? By using Pythagoras theorem. Here AC squared equals AB squared plus BC squared. So AC will be equals to square root 12 power of 2 plus 5 power of 2 equals to 13 meter in the direction of AC. Okay, now we can find the distance and the displacement for any shape. Let's go to another idea. Now we are going to study the directed line segment. What is the directed line segment? The directed line segment is the line segment which has a starting point, initial point, and ending point, terminal point, and a direction from the starting point to the ending point. So the directed line segment is the line segment which has starting point and an ending point. Okay, it has initial point which is the starting point, and it also has a terminal point, and it has a direction from the starting point to the ending point. Okay, if we are going to compare between the line segment which we studied before and the directed line segment which are going to study in this year in the first second. Okay, what is the line segment? The line segment, its ends are A and B. It has a starting point A. This is the line segment AB. It has a starting point AB and ending point. It has a starting point A and ending point B, or it has a starting point B and an ending point A. Okay, the starting point here is not determined. or the starting point here is not important. Here to study from A or to study from B, the same. And the length of the line segment AB is equal to the length of the line segment BA. But if we are talking about the directed line segment AB, its starting point is A. The directed line segment AB, its starting point is A, and its ending point is B, and is denoted by AB directed line segment. So this is the symbol of the directed line segment, half ray. Okay, I will write it again, AB and half ray, AB directed line segment. So it starts from A is the initial point, and B is the terminal point. So it has a direction. Okay, and AB directed line segment is not equals to BA directed line segment. Here, this is AB, here, this is AB directed line segment. But here, in the other example, you can find BA. This is BA directed line segment. Okay, so the first one is AB directed line segment, and the other one is BA directed line segment. So you can see that the length of AB directed line segment is equal to the length of the directed line segment BA, but in opposite direction. So we will write the negative sign because they are equal in magnitude but opposite in direction. Okay, so the directed line segment AB equals negative the directed line segment BA. Okay, let's go. Let's summarize what we are studying. The directed line segment, it is a line segment which has a starting point. So a line segment which has a starting point and ending point and a direction. Has a starting point, ending point, and a direction. The norm of the directed line segment. What is the norm of the directed line segment? The norm of AB directed line segment. It is the length of AB. It is the length of AB and is denoted by the symbol norm. So this is the symbol of the norm of AB directed segment, and the norm here means the length of the line segment AB. And you can notice that norm of AB directed line segment equal the norm of BA directed line segment equals the length of AB. AB directed line segment, its norm equals the norm of BA directed line segment equals the length of AB line segment. Okay, very important definition. Equivalent directed line segment. Okay, what is the equivalent directed line segment? Here, two directed line segments are equivalent if the first one, if they have the same length, or if they have the same norm, if they have the same direction. So two directed line segments are said to be equivalent if they have the same norm and if they have the same direction. Okay, let's go to an example. ABCD is a parallelogram. Its diagonal intersects at M, then complete. Okay, first we are going to draw the parallelogram ABCD. Here ABCD is a parallelogram. ABCD is a parallelogram. Its diagonals AB intersects and AC intersects at the point M. So we will write here, this is the point M. Okay. Here AB directed line segment is equivalent to AB directed line segment is equivalent to AB, its starting point is A and its terminal point is B, and this is the directed line segment AB. So it is equivalent to the directed line segment DC. So it is equivalent to the directed line segment DC directed line segment. Why? Because AB equals DC in length, because this is a parallelogram and they having the same direction. Okay, they have the same direction. DA here, DA, the directed line segment DA, okay, is equivalent to the directed line segment CB. So I will write CB. The directed line segment DA equals to the directed line segment CB because they are equal in magnitude and they have the same direction. Okay, they have the same length and they have the same direction. And what about MB? MB, okay, MB, the directed line segment starts, its initial point is the point M and its terminal point is the point B. So MB is equivalent to DM, and half the directed line segment DB, and it half the directed line segment DB. We all know that in the parallelogram the diagonals bisect each other, so the length of MB equals the length of MD. So the directed line segment MB is equivalent to the directed line segment DM. Okay, they must be equal in length and in the same direction. Okay, and what about AM? The same. AM here is equal to the directed line segment MC. They are equal in length, okay, and in the same direction. AM goes from A to M, and MC directed line segment will goes from the point M to the point C in the same direction. And this is equals to half the directed line segment AC. Okay, here BM, okay, BM here equals negative, BM equals negative DM, BM equals negative DM, okay, BM here equals negative DM because they are equal in length and opposite in direction. AM here, AM again is equals to negative CM, okay, AM here is equals to negative CM. Again AB directed line segment is equals to CD negative to CD directed line segment, and AD directed line segment is equals to CB is equal to negative CB directed line segment. Okay, again AB starts from the point A, goes to the point B. Okay, so it is equals to negative CD, they are equal in length and opposite in direction. AD here, AD, this is a directed line segment AD equals negative, okay, so it is equals negative CB because they are equal in length and opposite in direction. Let's go to another example. In the opposite figure, let's erase the first figure first. Example 2. Now we are going to start example 2. In the opposite figure, AD intersect BC, AD line segment intersect BC line segment in the point M. MA equals MD, MB equals MC. Then complete the following with equivalent or it is not equivalent, showing the reason. Okay, let's go. AM and MD, AM and MD. AM directed line segment in this direction, MD directed line segment in this direction. So AM equals MD, or we can say the directed line segment AM is equivalent to the directed line segment MD because they are equal, showing the reason, because they are equal in magnitude or having the same length, having the same norm. Okay, norm means here length, having the same norm and same direction. Okay, they have the same norm and same direction. MB and MC. MB here, MC in this direction. So MB is not equivalent to MC because they are in opposite direction. Because they are in the opposite direction. In the opposite direction. Okay. They are equal in magnitude or equal in norm. Okay. They are equal. Its norms are equal, and they are opposite in direction, so they are not equivalent. Okay. AB and CD. AB and CD. Okay. AB, this is AB directed line segment, and CD directed line segment. Okay. Okay. Here AB and CD, they are equal in magnitude and opposite in direction. Equal in magnitude and opposite in direction because the two triangles are congruent. The two triangles are congruent. Here we have AM equals DM and MC equals MB, and we have two vertically opposite angles. So the two triangles are congruent. As a result of congruency, we find that AB equals CD. Okay. Since AB equals CD, so AB directed line segment is equivalent to CD directed line segment because they have the same norm. Because they are having the same norm. Okay, they have the same norm and same direction. Same norm and same direction. Okay. Okay, and what about BM and BC? BM and BC. BM and BC, okay, they are not equivalent. Okay, BM and BC are not equivalent because they are not having the same norm. They are not having the same norm. Okay, or we can write it as here. Let's erase this. We can write it as because here norm. Because norm of BM directed line segment not equals to the norm of BC directed line segment. Okay, let's go to another example. Okay, thank you so much. Until we meet again next time, goodbye and good luck.